Hi everyone, today let's see about Cayley Hamilton Theorem. What is the statement of the theorem? Every square matrix satisfies its own characteristic equation. It means if we substitute the values of the square matrix in the characteristic equation, the right hand side values and the left hand side values will be the same. Now let us verify this theorem by using an example. Consider this example, matrix A. First, we are going to find the eigenvalues. To find the eigenvalues, we must find the characteristic equation. The characteristic equation is given by determinant of A minus lambda I, which is equal to 0. Now, we are going to substitute the matrix A in this equation. Lambda and I is the identity matrix, and find the characteristic equation. Matrix A. Here is the matrix A. I am writing here 2 minus 1, 2. Minus 1, 2, minus 1, 1, minus 1, 2, minus lambda into identity matrix. In identity matrix, all the diagonal entries are 1 and remaining other elements will be 0, which is equal to 0. See here, I am going to substitute the lambda inside this matrix directly. 1 into lambda, you will get lambda. 0 into lambda will be 0. So, leave it. 1 into lambda, lambda, and 1 into lambda, lambda. Now, we are going to substitute lambda I from this matrix. 2 minus lambda, we get 2 minus lambda. Minus 1 minus 0, there will be minus 1. 2 minus 0, 2. Minus 1 minus 0, minus 1. 2 minus lambda, 2 minus lambda. Minus 1 minus 0 minus 1, 1 minus 0 1, minus 1 minus 0 minus 1, 2 minus lambda, which is equal to 0. Now we are going to find the determinant for this A minus lambda I. Consider the first element 2 minus lambda into, leave the first row and the first column, remaining elements 2 minus lambda into 2 minus lambda minus 1, you get plus 1 into, leave the first row and the second column, minus 1 into 2 minus lambda, you get minus 2 plus lambda minus 1 into minus 1, you get minus 1, it will become 1 plus the third element 2 into, leave the first row and the third column, minus 1 into minus 1, you get 1. 1 into 2 minus lambda, you get minus of 2 minus lambda, which is equal to 0. Look at here, this is in the form of A minus B, the whole square formula. So, we are giving A square plus B square minus 2AB. Here, in the place of A, 2 is there, so 4. In the place of B, you have lambda, so lambda square minus 4 lambda. Here, minus 1. Plus 1 into now you will get the same value, need not write, minus 2 plus 1 you get minus 1 lambda minus 1, multiply this 2 inside, plus 2 into 2 minus 4, 2 minus 2 lambda, which is equal to 0. Next step, we have multiply this 2 minus lambda inside, 8 plus 2 into lambda square, 2 lambda square, 2 into minus 4 lambda minus 8 lambda, 2 into minus 1 minus 2, minus in lambda into 4 you get minus 4 lambda, minus lambda into lambda cube you get minus lambda cube, minus lambda into minus 4 lambda you get plus 4 lambda square, minus lambda into minus 1 you get plus lambda. You can simplify this side, lambda minus 2 lambda you get minus lambda, minus 1 plus 2 minus 1 you get minus 3, which is equal to 0. I am rearranging this, writing lambda cube values first, then lambda square values, plus 2 lambda square plus 4 lambda square you get 6 lambda square. Next lambda values, minus 8 lambda minus 4 lambda you get minus 12 lambda, plus lambda you get minus 11 lambda, plus 3 lambda you get minus 8 lambda. Next, constant terms, 8 minus 2, 6, 6 minus 3, you get 3, which is equal to 0. I am going to change the sign in the next step. Minus lambda cube becomes plus lambda cube. plus become minus 6 lambda square, minus becomes plus 8 lambda, plus becomes minus 3 lambda. This is the characteristic equation of the given matrix A. According to the Cayley Hamilton theorem, if you substitute the values of given matrix in this characteristic equation, the right hand side and the left hand side values will be equal. Now we are going to replace lambda by the given matrix A. Lambda as A cube, minus 6 lambda square as 6A square, plus 8 lambda as 8A, and minus 3 in the constant term we are introducing the identity matrix I is equal to 0. First we are going to name this equation as 1. Look at here A matrix is the given matrix, I we know this is the identity matrix, and we have to find A cube and A square. Now we are going to find A square values. A square, the given matrix A is here. I am going to find A square. A square is nothing, A into A. I am writing the given matrix. 2, minus 1, 2, minus 1, 2, minus 1, 1, minus 1, 2. 2, minus 1, 2, minus 1, 2, minus 1, 1, minus 1, 2. Simple matrix multiplication, that is rows into columns. First row into first column. 2 into 2 we get 4, minus 1 into minus 1 we get plus 1, 2 into 1 you get 2. The next first row into second column, 2 into minus 1 minus 2, minus 1 into 2 minus 2, 2 into minus 1 you get minus 2. 2 into 2 you get 4, minus 1 into minus 1 you get plus 1, 2 into 2 you get 4. Second row into first column, minus 1 into 2 minus 2, 2 into minus 1 minus 2, minus 1 into 1 you get minus 1. For second row and the second column, minus 1 into minus 1 1, 2 into 2 4, minus 1 into 1 you get plus 1. Second row and the third column, minus 1 into 2 you get minus 2, 2 into minus 1 you get minus 2, minus 1 into 2 minus 2. The third row and the first column, 2 into 1 2, minus 1 into 1 plus 1, 2 into 1 plus 2. Then the third row and the second column, minus 1 into 1 minus 1, minus 1 into 2 minus 2, 2 into minus 1 minus 2. Third row and the third column, 2 into 1 2, minus 1 into 1 minus 1 plus 1, 2 into 2 you get 4. Next we are going to add these all values and we are going to write in the next step. That will give you the A square matrix. 4 plus 1 plus 2 we get 7, minus 5 plus 5, minus 2 minus 2 minus 2 minus 6, 4 plus 1 plus 1 6, minus 1 minus 2 minus 2 you get minus 5. Then 2 plus 1 plus 4 you get 7. This is the A square matrix. Next we are going to find the A cube matrix. A cube is A into A square. I am going to write A square matrix into A. First I am writing A. A is here. The given matrix 2 minus 1 2, minus 1 2 minus 1, 1 minus 1 2. Now the A square matrix which we have found it here. 7 minus 6 9, minus 5 6 minus 6, 5 minus 5 and 7. Here is also we are going to do matrix, simple matrix multiplication, that is rows into columns. 2 into 7 you get 14, first row into first column, 2 into 7 14, minus 5 you get plus 5, 2 into 5 you get 10. First row into second column, minus 2 into minus 6 minus 12, minus 1 into 6 you get minus 6, 2 into 5 you get minus 10. Then we are multiplying first row in the third column, 2 into 9 you get 18, minus 1 into minus 6 you get plus 6, 2 into 7 you get 14. Next second row and the first column, minus 1 into 7 minus 7, 2 into 5 you get minus 10, minus 1 into 5 you get minus 5. Second row and the second column, minus 1 into minus 6 you get 6, 2 into 6 you get 12, minus 1 into minus 5 you get plus 5. Second row and the third column, minus 1 into 9 minus 9, 2 into minus 6 you get minus 12, minus 1 into 7 you get minus 7. Next we are going to multiply the third row and the first column, 1 into 7 you get 7, minus 1 into minus 5 you get plus 5, 2 into 5 you get 10. The third row and the second column, 1 into minus 6, minus 1 into minus 6, minus 6, 2 into 5 you get minus 10. Then next third row and the third column, 1 into 9, 9, minus 1 into minus 6 plus 6, 2 into 7 you get 14. Next step we are going to add and write. 14 plus 5 plus 10 you will get 29. Minus 2 minus 6 minus 10 you get minus 28. 18 plus 6 plus 14 you get 38. Minus 10 minus 10 minus 7 minus 10 minus 5 you get minus 22. Here you get 23, minus 28, 22, minus 22 and then 29. This is the A cube matrix which we have found now. And check in the characteristic equation. We have found A cube, A square and we know A and identity matrix. Now we can substitute the A cube, A square values in this equation and we can go for next checking. Take left hand side of the characteristic equation, LHS. To do in an easy manner, first I am going to consider only A cube minus 6A square. A cube minus 6A square. What we have found the A cube matrix is here. I am going to write here as it is 29 minus 28, 38, minus 22, 23, minus 28, 22, minus 22, 29. Look at here minus 6A square. I am going to directly multiply 6 in this matrix and write it here. Multiply each element by 6 and write. 6 into 7 you get 42. 6 into minus 6 you get minus 36. 6 nines are 54. Then 6 into minus 5 minus 30. 6 into 6 36. 6 into 6 minus 36. 6 into 5 you get 30. 6 into minus 5 minus 30, 6 into 7 you get 42. In the next step we are going to subtract this from this. You get 29 minus 42, you get minus 13. 28 plus minus of minus, so this becomes plus 36. 28 plus 36 you get 8. 38 minus 54 you get 16. Minus 22 minus of minus, so you get plus 30. Minus 22 plus 30 you get 8. 23 minus 36 you get minus 13. Minus 28 plus 36 you get plus 8. 22 minus 30 you get minus 8. Minus 22 plus 30 you get 8. 29 minus 42 you get minus 13. Now we have got A cube minus 6A square. A cube minus 6A square. Now we are going to add this by 8A. A cube minus 6A square plus 8A. A cube minus 6A square is here. We are writing it as it is. Minus 13, 8 minus 16, 8 minus 13, 8 minus 8, 8 minus 13. What is plus A? We are going to multiply the matrix A which was given in the question by 8. Multiply each element in the matrix A by 8 and write. I am writing multiplying 8 directly and writing it here. Multiply 8 in the first row. 8 into 2 you get 16. 8 into minus 1 minus 8. 8 into 2 you get 16. Next multiply the second row by 8. 8 into minus 1 minus 8, 8 into 2 16, 8 into minus 1 you get minus 8, multiply 8 in the third row, 8 into 1 8, 8 into minus 1 minus 8, 8 into 2 16. Now add this both matrices. Minus 13 plus 16 you get 3, 8 minus 8 0, minus 16 plus 16 0, 8 minus 8 0, minus 13 plus 16 3, 8 minus 8 0, minus 8 plus 8 0, 8 minus 8 0, minus 13 plus 16 you get 3. This is a cube minus 6a square plus 8a. Look at the characteristic equation. We found a cube minus 6a square plus 8a. Now we have to subtract the minus 3i from this one. I am going to do this in the next step. A cube, I am considering the left hand side of the characteristic equation fully. A cube minus 6a square plus 8a minus 3i. A cube minus 6a square plus 8a is here. That is 3, 0, 0. I am writing the last row 0, 0, 3 minus 3 into identity. 3 into identity matrix. All the diagonal entries are 1 and remaining entries will be 0. 0, 0. Multiplying 3 directly inside this matrix. 1 into 3, 3. 0 into 3 will be 0. 1 into 3, 3. 3, 3. Subtracting these both matrix, you will get 3 minus 3, 0. 0 minus 0, 0. 0 minus 0, 0. 0 minus 0, 0. 3 minus 3, 0. 0. 0 minus 0, 0. 0. 3 minus 3, 0. This is your left hand side. Characteristic equation. Look at here, it is 0. We got it. Left hand side is equal to right hand side. Hence verified. Hence our Cayley Hamilton theorem is verified. Thank you.